Okay, so picking up where we left off, um, let's move over here a little bit. Let's turn this to false so that we can pause the simulation even though it's already converged, just for good measure. And we'll start basically from our output here, which is our mesh. All right, and we're going to start setting up now a way to study what the form ends up being after we've optimized it for our planar material, which in this case will just be corrugated cardboard. But it will be a good stand-in for other kinds of planar materials. Similar processes could be applied. Okay, and there is one thing that I want to do before we get started here is to remember when we were talking about the edge points, and I was talking about kind of making our lives a little bit easier in the next step. So let's go back a little bit. Let's go back to Kangaroo here. Let's grab one of these shell components, the little light bulb, and let's put our edge points through that. All right, and let's go ahead. Even after the simulation is finished and we're paused here, this will still work. We can put this into another input here, into our entwine, bringing those points out and then through as a result of the simulation. Now this is going to go orange, so we can add another output here. And you'll see that the points are now being redrawn for us after the simulation. This is going to be very helpful. But the one thing that we're going to want to do next is to kind of partition that. So let's go to sets again. We'll partition this back into its kind of sets of points per side, so one set per side. If we do a count on that, it looks like there's 40, so just logically, since we put them in a certain order, we know that we can divide that by 4 and get 10, and we'll have 4 lists of 10 points each, corresponding to each one of those sides. Let's double check on that, so I'm just going to go to set here and tree and explode, and I'm just going to make sure that that's true. So if I select one of them at a time here, you'll see that this one set that's coming out of the first output there is that set, and then second, so on. And it stands to reason that the rest would be also fine, but we can double check. That looks good, and that also looks good. Okay. We actually don't need that because we have a grafted list, and I can work with that. So we'll kind of hang on to this, and we'll do some work to it in just a moment. Put it down here, maybe. All right. Let's start working with the mesh. Now we have a mesh that we don't need to. We need to kind of treat it kind of as a base condition now, and we're going to do some new things to it. So I'm going to go to Kangaroo 2 here and grab a couple things. First, let's talk about the planarization. Right. So goals mesh, you'll find planarize. Okay. So let's do that. We'll input this mesh into the planarize goal. And this one's going to need a bunch of strength, so I'm actually going to choose to do a power of 10 here. So I'm going to go to math, polynomials, and you'll find the power of 10 component. And then I'm going to put a slider on that between 0 and 5, should be enough. Like this. And we'll start the simulation out with 0 as an input there. Let's make that a little bigger so it can work. Alright, head back over to Kangaroo. We're also going to need to kind of smooth this a little bit as we work. This will kind of keep things from getting a little bit unruly as we apply this planarization routine. So I'm going to grab this smooth. It's got a little iron on it there. Same mesh will be input into that. And the strength on this we can actually keep pretty low. It may not, it doesn't appear to do a lot, but it actually does. But we'll just keep that at 1. And before we forget, let's drop in a light bulb on that so that we can kind of bring that mesh forward through our solver. Okay, so we're starting to get set up here. A couple more things, and this one gets a little bit more tricky, but it's going to be how we treat, and we'll get to this one later, but it's going to be how we treat the anchor points. So let's first of all establish those anchor points. All right. And to do that here, kind of show you another little technique that I use sometimes, which is I'll go back to this mesh area here. I'll grab the naked vertices component. I'll bring the mesh out again, and I'm going to turn that one off. I always like to turn this one off because it's busy. From the naked points, I'm going to sort them, but first I need to know what their z value is. So I'm going to go to vector and deconstruct point here to find its z value. Then I'm going to go to set, list, and sort, and I'm going to put the z input into k here. These are the numeric keys that I'm going to order from small to large, and I'm going to compare the points themselves to those lists, to those values, so that I can kind of order them from high to low, basically, or low to high. And what I'm doing basically here is I'm going to make a distinction between these lowest points, where the footings are, and the edge points. But since I already have the edge points, I can pull those from the other list that we've used over here. Get to that in just a second. So the first thing is going to just be to simply kind of check whether or not these points are at a certain height in space. And if they're anything higher than something very low, 0.5 or 0.1 or 0.2, then I know that they're already taller, or they're already higher in space than my footing, and I already know that I don't want the rest. Okay, so let's go over to math, and we'll choose smaller than. What we're measuring are the sorted points, sorted numbers, and we'll get to the points in a moment. We're going to compare it to a number that's, just say, default 0.25. Or let's crank it to 1. I think that'll be completely fine. Alright, so here's what we have. And now we're going to get out of this a bunch of trues and falses. So it's going to be true if this number, A, is smaller than that number B. And when that's true, that's the point it's going to select when I bring this into a call pattern. So I'm going to go to set, sequence, call pattern. Call pattern is going to look for a pattern of trues and falses. The input for the list is going to be the points that are coming out of A, so pay kind of close attention to that. This could be a good spot to kind of pause and take a look. Excuse me, to make sure that you're doing the same thing here. Okay, so A goes into there, and we have our pattern coming into P from the smaller than component, and this should give us just the points, as you can see here, that are at the very lowest level of all the naked point options. I suppose another way that we could have selected those other points is to just inverse this Boolean, but since we already have them, I won't fuss about it. And there's another reason why we wanted these partitioned in the way that they are, and we will see that in a future step. Okay. Now these I know that they're always going to be anchored. Okay, so let's go over here and grab our anchor. That we know is true. Those are going to be anchored no matter what. The other ones, though, we may want to anchor. So I'm going to have the option for that, but I'm going to keep my options open as well. And one thing I want to try is this anchor XYZ to see if these points give us a little bit more control over the form in the end during the planarization. So if you can kind of follow along a little bit here, I'm just going to pop in that XYZ, and then during, oops, and then I'll see what happens if I constrain their movement into only the z direction. Okay, so you can get caught up with a little pause here. Okay, and then lastly, before we go ahead and set this thing up, I'm going to go to mesh here, grab my mesh deconstruct, just to find the vertices in the mesh. And I'm going to kind of keep these from dragging around too much. I don't want these to move a whole lot. Alright, so, and to do that, I'm going to, this may not have much of an effect, actually, we can check later, but just kind of a standard operation for this sort of thing is to go to Kangaroo. We'll grab this plastic anchor component here, down at the bottom of goals point. Those are going to be your points, and then we'll input some stuff into this. I'm going to just input 0.3 into the L input here, so this is going to be at around that distance, they'll start to slide ever so slightly. The strength we want to leave pretty low also here. Sorry, the strength we want to keep, the strength we keep quite high. Actually, sorry, let's start that over. This is going to be 0.03, something very small. And we are going to set our strength to something also pretty minimal. Just say 0.5. Okay, apologies for the little bit of confusion there. I had to double check on something. Okay, so this is where we're at here, right? Plastic anchor, low strength, and a low distance that will limit the target points. Okay. Let's go over to sets. We'll grab this entwine, and we'll start placing things in. All right, so this is going to be, we'll kind of go in the order that seems to make sense. We'll keep the mesh, coming in first so that we can get that out nice and easy. And then the rest of these, the order matters a little bit less, so I'm just going to start putting them in order, in the order basically that they appear on screen. Should be fine. And I'm going to leave the plastic anchors out for a moment, just to show you, so we can take a look at what the results are without it. Let's go grab a solver. Bring that in. Before we get too ahead of ourselves, let's make sure we have our boolean and our button. Okay. And again, what I like to do is clean up the data coming out. So I'm going to go back to sets, tree, and clean. I'm going to turn this to true, the E input to true, although in this case it may not matter. And I'm also going to start turning off previews from before. Okay, so go all the way back, turn off that preview. Points, I suppose, don't really hurt us too much, so we can leave those on for now so we can reference them. And I'm going to reset that so that we have a base condition here that we're working with. And then I'm going to go back to sets, tree, and explode, and just kind of give myself the option here to kind of pull out those two data points, data streams. Really the one that we need here is the mesh. Okay, so and I guess in order to test this planarization, what we're going to want to do is extract the polylines from these mesh faces. So let's go to mesh. We'll grab this little face boundaries component there. It looks like a triangle. We can turn that off. And then I'm going to go to surface and boundary surfaces here. And this is only going to draw a surface when the profile is planar. So this is a nice little check for us. And as the simulation runs, we'll be able to determine whether or not we're finished. And the thing that we're going to increase in strength is the planarization here. All right. We can leave the other inputs alone. Let's put a little highlight around that so we remember. So I'm going to go ahead and hit true and give us some breathing room here. And as I increase this slider, what we should be seeing is a change in form, and also the surfaces start to emerge. Now, you can see that we didn't constrain those outer points. And what we're getting is the planarization forces are having too much of an impact on that outer edge. It's really kind of destroying it. Technically speaking, the simulation is satisfied. It did what we asked it to do. It planarized the faces. And in order to do that, a formal change has to happen. To get rid of the twist and keep a seamless connection, you're going to need to change the form ever so slightly. But what we don't want to do is destroy our edge here. We don't want to build this. This looks a little bit bad. So let's try a couple things out here. Let's drop this back down, hit reset, okay? And let's just go ahead and take these outer points, the ones coming out of the partition here, and let's just add those holding shift to our anchors. All right, let's see what this does now. So let's crank this up. Now we're holding, we're holding the line nice and tight, but let's take a look at what this does to the form. That energy that we're applying has to go somewhere, and it's going to manifest itself by kind of bubbling out the surface a little bit more, creating more of like an igloo form, if you will. Um, Now this is a more satisfying result. This result is aesthetically much nicer, structurally makes a lot more sense, right? Holding a strong edge, the arcs are quite rational, and the whole structure is quite symmetrical overall. But we have to look at this, whether or not this is something that we really think is the kind of most elegant version of this, I guess. We could, this is a judgment call, right? We can work with this exact form, um, although we've lost, a good amount of where we started. If something like this is the target, if this mesh is the target, you can see that we're quite a distance away from that at this point. This line may have held true, but actually the form is very different. Okay, so you have to make a decision on how you want to go back and forth here. Versus, it's basically a decision between the reality of building it versus your initial vision for it. But we have options. We don't have to stop here. I'm going to go ahead and disconnect that partition there. I'm going to turn that slider back down again, start from the beginning. And then let's go ahead and drag in this anchor XYZ goal into the entwine. Okay, we'll hit reset again. And now let's see what this does. Remember, these edge points have been removed from their anchors. They've been now added as anchor XYZs. It's a little bit different. So take a look at the screen there to kind of catch up with where we are. And we're looking at different options here. So now as I start to planarize this, I get a form that's a little bit more similar to where we started, although what we've done is we've dropped the height of those outer arcs quite a bit, making this much harder to step into. If this is roughly 10 feet or something, this is going to be very low, forcing people to sort of dip down and inside, which is okay, I guess, in some contexts. In this case, I think we want to make those arcs a little higher, and we want to try to keep them more or less where they were. So the question is, what do we do here? What can we do that can control this a little bit more carefully? Let's go ahead and turn this back down. Okay, let it reset. Let's disconnect this component here. And let's try one more thing. The points that we have partitioned here, because they're on their own separate lists, let's run these through a coplanar goal, right? So let's go to kangaroo, we'll go to goals angle, goals co, and we'll find coplanar as one of the options. Let's put these points on a coplanar goal, okay, and let's set that strength to, I don't know, this probably doesn't matter as much because this is a pretty strong goal, but let's set it to 50. Make sure of it. And let's put that into the input in the entwine here. Now what this is going to do is going to take those sets of points and it's going to allow them to sort of rotate in space. They'll kind of pull, but they're going to stay at least straight. They're going to kind of continue to create a straight arc at least. So let's take a look at this maybe from this view or something. And we'll hit reset, make sure everything's cool, and we'll go ahead and start to increase our planarization. Now you can see what happened there. It started to tilt kind of inward a bit, and there's a bit of a shrinking of the mesh faces. I'm going to go ahead and turn these off. There's a bit of a shrinking of those mesh faces toward the outer edge, and but that's okay. If anything, what we have now is a solution that we could consider to be quite a good compromise. Formally, I think it's still pretty elegant, similar to the first one, and at least in spirit. The outer arcs though have been tilted inward, and they have a little bit of a flare moving up, right? So it sort of really defines the edges in a nice way, defines the openings, might even add a little strength. With that little fold line there, could actually add some stability to the outer, right, the outer edge. And we've also, at the same time, satisfied our planarization, right? So all the surfaces are now complete. So this is going to be the form that we're going to work with, at least as an option. The other thing that I think it does is it produces a pretty nice plan view. You can kind of see the sort of opposing curves of the mesh edges as it goes, like super positive curvature here, more dome-like in the middle. as it kind of tilts back down to being a little bit, that little moment of negative curvature where it turns into the arc on the outer edge. Take a look at the 4 views for more feedback. Right. And yeah, I think this is a good place to start. The next process, which is one more planarization routine. But I did just notice something. Let's do that again here. Now, because these points over here, they don't include that base corner, what we're actually seeing is a little bit of a kink at that moment right there. Like these points from here all the way around to that other point is planar, the kind of coplanar. You can see that right about there, but we have a little bit of a kink. This is something you could live with as a design, idea. Or if we want to straighten this point out a little bit so it matches that corner, we're going to have to include that corner in this goal here. All right. So a real quick way to do that is to let's go ahead and pause this, reset it, bring it back to where we were. Now we could do this in Grasshopper. We can probably pull out our anchors, figure out which side they're on, etc., etc. I'm just going to make it fast, and I'm just going to bake out these naked points here into Rhino. So I'm going to hit bake, and go ahead and turn that off. And then what I'll do is I'll bring in the points that I want in sequence. Okay, so it's starting with the corner, and then I'll pull in these edge points here. All right, kind of like what we did before, except this time. And then I'm going to go in order. I can do this all in one swoop, so long as I'm in order. Working manually in this case, because I have a very clear idea for what the result of this is going to be, I think it's completely fine. I don't really need parametric control over this. I could get it just to kind of demonstrate options, kind of like what we did with the other anchors, but or with the other options. But for the sake of time in this tutorial, I'm just going to do it this way. Okay, so those are all kind of input now. I can now partition those again. Okay, but there's going to be more than 10 per. There are actually going to be 12 because we added 2 per side. Okay, so let's turn that off. We can go ahead and hide these points. We don't need to see those. Let's hide those. And let's see if that gives us a little bit of a better edge here. So I'm going to set up my view and go ahead and run this. There we go. Yeah, very nice. Yeah, that's a much cleaner edge if you ask me. That coplanar edge, it's good. Okay, so this should wrap up our form finding, and we're getting closer to construction limitations. The next step is to give it thickness. Okay, so we're going to need to offset it. We're going to need to give it a little. We're going to need to loft up the little webbing in between, and we're going to have to make sure that all of that is planar. So the offset has to be planar, and the linear frame between the two surfaces will have to be planar as well in order for us to fully accommodate the limitations of our material. All right, so we'll do that in the next step.